Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of Geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of Climatology. Today we'll be starting with Module 6 of Climatology, which is Frontogenesis, Cyclones and Anticyclones. The lecture 1, which we'll be starting today, we will be discussing fronts and frontogenesis. The video is being recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Hello dear learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun, Uttarakhand. We have already covered several important topics of climatology, and this particular module is the second last important module of climatology, which is associated with fronts, frontogenesis, cyclones, and anticyclones. So let's begin. The main objective of this particular video is to understand what is a front and what are the conditions which leads to the formation of fronts in various regions of the world. How these fronts are created, what is the classification of fronts, and what are the weather conditions which are associated with fronts or frontal regions of the world. And finally, we'll be discussing what are the various frontal zones of the world. So starting with fronts and frontogenesis. When we were discussing the chapter on air masses, we have briefly discussed what fronts are. So fronts are generally formed in regions where there are contrasting air masses, and those contrasting air masses want to converge. But because of contrasting properties of temperature, humidity, etc. in those air masses, they are not able to completely merge together, leading to the formation of transitional boundary zones in those areas. And these transitional boundary zones are the zones of turbulence, and numerous weather conditions and phenomena exist in those frontal regions. So fronts are sloping boundary zones between the two opposite air masses having contrasting characteristics in terms of air temperature, humidity, density, air pressure, and wind direction. So these are not only the transition zones or boundary regions, rather they are complete weather systems and inclined zones along with two opposite air masses having contrasting characteristics in terms of their air temperature, humidity, density try to converge together. So in this process, what happens? They create extensive transition zones representing zone of discontinuity, with one type of air mass is usually denser than the other, with differences in temperature and different level of humidity. And while they try to clash each other, the air types causes unique weather condition in these areas, causing rainfall, snow, cold days, hot days, and windy days. So fronts are specifically called as unique weather systems which exist in certain parts of the world where the difference in the characteristics of converging air masses is very, very vivid. So as you can see in this particular slide also, that you have cold air masses, you have warm air masses, you have air masses originating over the continents, you have air masses originating over the ocean water. So based on that, we have extensively discussed the air masses, but there are certain areas, just like this particular area, where the very cold air masses coming from the Arctic region collides with the warm air masses coming from the tropical regions. So here in these particular areas, very extensive fronts are created and they have weather system of their own. And these particular extensive frontal regions are also zone of temperate cyclones because of extreme contrasting nature of air masses coming from north and warm air masses coming from south. The temperature and the humidity conditions are so extensively diverse that it lead to the formation of temperate cyclones also, and these areas represent cyclonic activity zones of the world also. So you can see in this particular slide, but I'll not be going into much details of each and every air mass because we've already discussed them. Fronts exist in specific regions of the world where we have contrasting air masses. So the process which is associated with the creation of a new front is called as frontogenesis, while the process which is associated with the destruction or dying or dissolution of front is called as frontolysis. So once these fronts are formed, wind movement in these frontal zones is affected by the Coriolis force also, just like any other wind movement in both the northern and southern hemisphere. So in northern hemisphere, the frontogenesis happens in an anti-clockwise direction, while in the southern hemisphere, the frontogenesis and associated wind movement is generally in the clockwise direction. Once these fronts are formed, they are greatly affected by Coriolis force, and the impact of Coriolis force in the movement of winds we have already discussed in module 3. So in the northern hemisphere, the winds are deflected towards their right, while in the southern hemisphere, the winds are deflected towards their left because of the impact of Coriolis force. So therefore, when the fronts are created in the northern hemisphere, the associated wind movement in those frontal regions of the world is mostly anti-clockwise in the northern hemisphere, while it is clockwise in the southern hemisphere due to the impact of Coriolis force. And these frontal regions of the world mainly exist in the temperate zones of the world, which generally extend between the 40° to 60° north and south latitude in both the hemisphere. And these particular mid-latitudinal zones or the temperate zones of the world are also affected by the temperate cyclones, which are also called as extratropical cyclones. So the mechanism and the formation of temperate cyclones will be dealing in the coming videos, but you have to understand now that these temperate cyclones of the world are also created in these frontal zones only. So these are the outcome of the process of frontogenesis in these temperate regions, and these particular regions showcase very turbulent weather conditions with torrential rainfall, with extreme climatic condition, extremely cold warm time periods, and varying wind velocity also. So extremely turbulent weather conditions may exist in these regions due to the formation of fronts and due to the outcome of the existing cyclonic activity in these regions. So just a little picture is here to show you that when the contrasting air masses meet, what happened in these temperate regions of the world. So the storm-like conditions are created over the Lake Superior in USA due to the incomplete convergence of the contrasting air masses. And you can see that a shallow boundary is formed between these two contrasting air masses, leading to the conditions of storm. But frontogenesis does not happen in any regions of the world. There are specific necessary conditions for frontogenesis to happen or for the creation of fronts. First of all, the very important condition, as we have discussed, is the presence of two contrasting air masses where they differ in their properties, physical properties like temperature, air pressure, density, and humidity. So when we will have two very contrasting air masses, there will be differences in temperature and other physical characteristics of those air masses, then only turbulent conditions will be created and then only the conditions for the fronts will occur. Second is the temperature differences. So within the physical characteristics, the temperature difference is one of the most prominent and important feature of air masses and the consequent formation of fronts. So when two opposite air masses collide together, they must have contrasting temperatures. That is, one air mass should be cold, dry, and heavier, while the other air mass should be hot, humid, and light. So, in such conditions, only one of the two air masses become aggressive and try to invade the area of the other air mass, leading to conditions where fronts are created. And third important condition is direction of air masses. So if the air masses are of contrasting nature, but they are moving in opposite direction, they will not lead to the formation of fronts. The formation of fronts is only formed when the contrasting air masses are moving face to face in direction. So these are the zones where the fronts will be formed. So they have to move in the face to face direction in order to converge. So when air masses diverge, they move in opposite direction and frontogenesis does not form. Along with all these conditions, the deformatory circulation is also very important and necessary condition for frontogenesis, which involves the convergence of two air masses which are contrasting and horizontal spreading along a line which is called as axis of outflow or axis of dilation. We'll just discuss this in another slide. While the other axis is called as axis of inflow. So while these two particular air masses are converging together, they should converge in a manner that there is an excess of outflow and then there is an excess of inflow. So this type of air circulation is most favorable for the formation of fronts and frontogenesis. So these are the four most important conditions which are required for the formation of fronts. So just understand what deformatory circulation is. So when these two contrasting air masses are converging in a deformation circulation, they spread along this particular horizontal line. And while they are spreading in this particular formation, in such situation, the creation of front depends upon the angle between the axis of outflow and the isotherms. So fronts do not create when this angle exceed more than 45 degree. So fronts are neither created when this angle is vertical nor created when the angle is completely horizontal. But when this particular angle is 45 degrees, it is the most plausible condition for the formation of fronts. So as the convergence of air continues, this angle decreases and isotherm try to become parallel to the axis of outflow and frontogenesis is activated. So this is the particular situation where the deformatory circulation leads to the formation of front, where you have the axis of inflow at one end and then you have the axis of outflow at the other end. Frontal zone is neither parallel nor vertical to the ground surface. Rather, it is inclined at low angle, which is 45 degrees of angle. Besides the necessary conditions, as we have just discussed in the previous slide, the steepness and intensity of front also depends upon the temperature gradient. If the temperature gradient is very, very sharp, it is steep, the intensity of front will be high. Whereas if the temperature gradient is low, the intensity of front will also be low. Besides the intensity of front, if the two contrasting air masses are parallel to each other and there is no upward displacement of air, it leads to the formation of stationary conditions which are called as stationary fronts. So we will be just discussing all the types of front one by one in the coming slides, but just understand, so if the cold air mass and warm air mass lie parallel to each other and there is no upward movement of the air, it leads to the stationary conditions, and these conditions are climatically insignificant because there is no cloud formation and there is no precipitation. But such situation exists very, very rarely. Why? Because two contrasting air masses tend to converge together, and generally they are separated by a sloping boundary due to deflective force of Earth, where the cold and dense air mass pushes the warm and light air mass upwards. So these type of conditions exist very rarely. In general, because of the deflective nature of the winds, the cold air mass becomes aggressive and try to invade the area of warm air mass, and in the process the warm air mass, because it is lighter, it tends to rise above, leading to the creation of clouds and formation of a shallow boundary zone between them, which is called as front. So these frontal zones are zones of unique climatic conditions and weather phenomena. So fronts are not linear between two converging and contrasting air masses, but they are zones. It is not just a single particular boundary which exists between the two air masses. They have extensive spatial dimension, and they are rather zonal in nature, having width of 5 to 80 kilometers in specific regions of the world, which are mostly temperate regions. Types of fronts. Based on the nature of convergence, relative acceleration of air masses, and stages of front formation, four types of fronts are identified. The first one is warm front, where the warm air becomes aggressive and lead to the creation of fronts. So in climatology, various meteorological symbols are used to depict the different types of fronts, which are mainly used for weather monitoring and forecast purposes. So for warm front, you have this particular type of symbol where red rounded structures are formed over this particular line. Then second, you have cold front, where the cold air become aggressive and lead to the formation of front. So generally they are depicted by blue conical structures over the line. Third type of front is stationary front, which as the name suggests is stationary in nature, and it is depicted by this particular type of symbol. And then finally you have the occluded front, which is depicted by this particular symbol. So in totality, you can see that when the warm air becomes aggressive, the warm front is created. When the cold air becomes aggressive, cold front is created. The stationary front exists when warm air and cold air lie parallel to each other with no vertical movement. And then you have occluded front, which is a specific type of front which is formed during one of these stages of front formation. So all these types of fronts are created. Let's discuss them one by one now. Starting with warm front. The warm front is a gently sloping frontal surface along which the warm and light air becomes active and aggressive and rises slowly over the cold and dense air. Due to this, the condensation takes place gradually. Why the condensation takes place gradually? Because the warm front is a gradually rising front, and therefore the cooling of air takes place gradually, leading to the formation of clouds in the frontal zones, yielding precipitation for the longer hours. So when a warm front air mass collides against the cold air mass, as you can see in this animation also, it rises above the cold air mass, which is relatively heavier and denser, because of which it wants to remain near to the ground. And the warm air being lighter is forced to rise up this particular front, leading to the formation of nimbostratus, altostratus, cirrostratus clouds in this frontal zone. And these clouds produce moderate to gentle precipitation for very long hours. So a warm front is a gently sloping frontal surface along which the warm air gets cooled gradually, leading to the formation of nimbostratus, altostratus, cirrostratus clouds. And in these frontal zones, we can see that there's a gentle precipitation for long durations. Besides warm front, we also have cold fronts. So in these particular zones, what happens? It is a steep sloping frontal surface along which the cold air becomes active and aggressive and enters into the warm air territory, followed by rapid condensation and precipitation. When the cold air becomes aggressive, it tries to invade the area of warm air. The front which is formed is quite steep, as you can see in this diagram also. So along this frontal surface, because the warm air is quickly lifted, what happens? It leads to sudden condensation and precipitation occurs. It is formed when the cold air mass initiates the movement. So the initiation of the movement is coming from the cold air mass instead of the warm air mass, and it hits the warm air, forcing it to rise up. As you can see in this diagram also, that the warm air is rising along the cold frontal zone, leading to the formation of cumulonimbus clouds. And these areas are also zones of severe storms which can occur during the summer months. Thunderstorms are common in the warm sector. Why? Because the warm air is suddenly forced to rise up along the steep cold front, and hence the air rapidly cools down, leading to formation of dense cumulonimbus clouds, and heavy precipitation is witnessed in these areas. In regions like USA, tornadoes also occur in the warm sectors. Cumulonimbus clouds are formed, leading to heavy rainfall followed by thunder and lightning also. And sometimes these cold frontal precipitations are also associated with snowfall and hailstorms also, because the warm air is suddenly and quickly lifted up, because of which the air sometimes get cooled to sub-zero temperatures, leading to snowfall and hailstorms also. So cold fronts are generally steep sloping frontal surfaces along which the warm air rises very quickly, leading to heavy precipitation and very dramatic weather and climatic conditions. Besides warm and cold front, we also have stationary fronts. In this type of particular fronts, the two air masses having contrasting physical properties rest against each other without showing any major vertical movement. So weather generally remains stable, but sometimes it might rain also, depending upon the dominance of cold front or warm front. Atmospheric conditions remain more or less stable along these frontal areas. Within the fronts, however, the atmospheric condition can suddenly change across the stationary front. If either cold air becomes aggressive or warm air becomes aggressive, the stationary front may convert into cold front or warm front, depending upon the aggressiveness of the cold air or warm air. Cyclones migrating along the stationary fronts can dump heavy amounts of precipitation also in these zones, resulting into significant flooding along the frontal areas. So as you can see in this diagram also, and the animation, that the cold air and warm air are resting parallel to each other, leading to the creation of stationary front with very little precipitation in these areas, but may quickly turn into either cold front or warm front, depending upon which particular air mass becomes aggressive along the stationary front. Occluded front. When the warm air mass is completely raised over the cold air mass, it can be called as occluded front. Weather along this sector is a complex mixture of cold front type and warm front type. And this type of fronts are very common in Western European areas. The formation of mid-latitudinal cyclones or temperate cyclones also involves the formation of occluded fronts, because the cold air has completely taken up the territory of warm air, and the warm air is completely tossed up above the cold air mass, leading to the formation of occluded front. So it is a kind of front which is associated with aggressive cold air mass frontal movement invading into the zone of warm air mass, completely tossing the warm air mass, leading to the formation of occluded front. And these types of front are most favorable when there is a formation of temperate cyclone in these zones. So we'll be studying in depth about the occluded front and how they are formed in detail when we'll do the temperate cyclones. So for now, you have to understand that occluded fronts are the manifestation of aggression of one of the air mass, primarily the cold air mass, which enters aggressively into the warm air territory and completely uplifts the warm air mass, leading to the formation of occluded front. As you can see in this particular diagram also, that the cold air mass is invading the area of warm air mass, and in the process the occluded front is formed. So what are the weather conditions associated with fronts, and how do weather condition changes with respect to different fronts? So as you know that fronts are formed due to convergence of two air masses of contrasting temperatures, and hence the contrasting weather conditions are found from north to south or south to north, depending upon which particular air mass is becoming aggressive and invading into the arena of the other air mass. Differences in temperature, humidity, precipitation, cloudiness, and wind direction are experienced along various sectors of these frontal activity. You can witness drastically changing weather conditions. Now, there are different weather conditions associated with different types of front. So, weather conditions which are primarily associated with warm front includes when the warm air becomes active and aggressive along the warm front, it invades the zone of cold air, and thus because it is lighter, it gradually rises over the cold air and it is cooled adiabatically from below. Cooling of warm air causes condensation and cloud formation along the gently rising warm front. If the aggressive warm front is stable and it is less humid, condensation occur at greater height, leading to much lifting of air and gentle precipitation thereafter takes place. On the other hand, if the warm air is moist and unstable, only a slight lifting causes condensation and precipitation takes place. So the warm front precipitation is primarily for longer duration. It is much more moderate, but it is widespread because of gentle slope of warm front. So it is very, very clearly evident in this particular animation. Also, you can see that how the warm air is gently rising along this gentle frontal surface, and in the process various types of clouds are formed in the region nimbostratus, stratus, altostratus, leading to light precipitation in these particular zones for longer durations. So you can see that there are frequent changes in the cloud type. The sequence of cloud from above to down comprises of various types of clouds like the cirrus cloud, cirrostratus, altostratus, stratus, and nimbostratus. So you can see that when a warm front advances forward, the warm sector comes over the observation place, and there is a sudden change in the weather conditions with the arrival of warm sector, which leads to sudden increase in temperature and sudden increase in the specific humidity of that region. Also, along with this, you can also see there is a decrease in air pressure and disappearance of fair weather clouds and clear sky, leading to precipitation. But sometimes you can also see breaks in precipitation because the warm air gently rises up, leading to the formation of various types of clouds. So while the clouds are forming, you have breaks in precipitation also along the frontal surface. Now let's see the weather associated with cold fronts. So when the cold air becomes aggressive, what happens? The cold and dense air becomes active and aggressive along the cold front, wherein the cold air invades the warm air region and pushes it upwards, while it, being denser, settles downwards. So what happens if a cold front exists? A steep cold front is formed along the area of convergence, And as you can see in the diagram also, along which the warm air is quickly forced to move upwards, leading to the formation of very dense cumulonimbus clouds, leading to heavy precipitation in these cold front zones. So if cold front passes away soon, weather also becomes clear soon. Otherwise, if the front becomes stationary, the sky remain overcasted with heavy cumulonimbus clouds, provided that the cold air is moist and unstable. And frontal thunderstorms are also very common in these areas. So heavy precipitation occurs, but the precipitation is primarily of short duration as compared to the warm front where the precipitation was gentle and for longer time periods. So in the cold front areas, the consequent weather is characterized by the decrease in air temperature, increase in air pressure, decrease in specific and relative humidity also, and changes in wind directions. Precipitation is also accompanied by lightning and cloud thunder because of the formation of cumulonimbus clouds in these zones. Sometimes the rainfall is also associated with hailstorm because the warm air suddenly gets lifted up and it cools down, and sometimes the temperature is very low, leading to hailstorms. So after the passage of cold front, clouds disappear, precipitation also terminates, and weather becomes clear and northwest cold winds set in. So these were the changing weather conditions associated with warm front and associated with cold front. So you can see the evolution of the cold front in North America in January, and a very high pressure region exists over the central Canada, which leads to the formation of continental Arctic type of air masses, which are very cold and dry air masses originating in continental interiors of Canada. And once they are formed, they move southward and tend to bring the cold and chilly conditions to the central Canada region and central USA regions also. And in the process, they collide with the maritime tropical air mass, which is comparatively warmer and moist, and leads to the formation of cold fronts in these zones, because both the air masses have very contrasting properties, hence they are not able to converge properly. But because the cold air is more aggressive in this particular area, it leads to the formation of cold front. And then the cold front keeps on moving towards the south, bringing cold and chilly conditions in this particular area, and heavy precipitation is witnessed in this part of the North American region. And this is the time period when this area also witnesses the temperate cyclones. And then in the final phase, the cold air mass completely invades the region of maritime tropical air mass, which was initially existing in day one. So it completely invades the area, bringing very dry, cold conditions in the whole North American region. So you can see here that this continental Arctic air mass is continuously interacting with the maritime polar air mass coming from the Pacific area also, and it also keeps on pushing southward, bringing cold and chilly conditions to the southern parts of America also. So this is how the evolution of cold front takes place over a particular territory. So as we know now that fronts are not formed everywhere, but they are formed only in those areas where two air masses of different physical properties try to converge. So major frontal zones of the world are primarily three. First one is the polar frontal zone, second is the Arctic frontal zone, and third is the intertropical frontal zone. So the frontal zones of the world are closely associated with the source regions of different air masses. So polar frontal zones are generally formed in the mid-latitudes in both the hemispheres, and these are also called as Atlantic polar frontal zones. Why? Because of the formation of fronts mainly takes over the northwestern part of the Atlantic Ocean, and they are mainly formed because of the convergence of the polar continental air masses, which are cold, dense and dry, and the tropical maritime air masses, which are warm, moist and light. So you can see in this particular diagram also that the formation of continental polar type of air masses leads to the formation of these polar frontal zones when they develop over the cold, dry continental areas in the polar zones and then try to aggressively move southwards, invading the area of the maritime tropical air masses, and in this process they lead to the formation of the polar frontal zones which extend covering various regions of North America and the North Atlantic Ocean primarily. So when they develop over northern parts of Pacific Ocean also, they are called as Pacific polar frontal zones. So you can see in this diagram also that maritime polar air mass is also coming from the northern parts of the Pacific Ocean, and it also collides with the continental polar air masses which are formed in the Northern American region. So because of the interplay of various air masses which are formed in the polar regions, whether over the polar maritime areas or polar continental areas, when they collide with the air masses coming from the south, which are primarily moist, warm and light, it leads to the formation of polar front, and they are most active during the winter season. Why? Because there is a more profound contrast between the various air masses which are found in these regions. So regions of intense cyclonic activity also exist in these regions, for leading to the formation of temperate cyclones because of the extremely contrasting convergence of the air masses in these areas. Another section of the polar front is also referred to as the Mediterranean front within this polar frontal zone only. So this frontal zone is formed over the Mediterranean areas, as you can see here in the Mediterranean areas, mainly due to the convergence of cold continental European air mass and air mass of North Africa along the Mediterranean Caspian Sea line. Cold European air mass coming from north and the warm African air mass coming from south collides over the frontal line in the Mediterranean Caspian Sea region. So the winter cyclonic storms are developed over the Mediterranean basin, which moves towards the east and northeast region, and some of these frontal weather disturbances also reach Pakistan and India, leading to the western disturbance induced precipitation in northern India during the winter season. Besides polar frontal zones, we have Arctic frontal zones which are formed north the polar frontal zone areas. So Arctic frontal zones are mainly formed due to the convergence of continental and maritime polar air masses. So you can see here in this particular diagram that because of very low temperatures, the continental Arctic type of air masses originate in these chilly climatic conditions which tend to move southward once they are formed, and they are very aggressive and they try to invade the area of the maritime polar type of air masses or continental polar type of air masses because they are much more colder than these two polar air masses also, and in this process a thick cold front is formed in the Arctic zones of the world. So polar maritime air masses in this case are having higher temperature as compared to the continental Arctic air masses. So comparatively, when the warm polar maritime air masses meets with the extremely cold and chilly Arctic air masses, the Arctic frontal zones are created. So within these zones, when the fronts develop over the Pacific regions, they are called as Pacific Arctic frontal zones, which can be seen over the northern United States in winter months and move south eastwards, bringing intense cold, chilly waves throughout the North American region. So as you can see in this map of North America, also the northern part of Canada and Arctic regions are very cold, which leads to intense high pressure in these areas because of very cold condition, which leads to the formation of cold, dry, dense air masses. And when these air masses are formed, they move southward, leading to the formation of cold fronts in these zones. And over the time period, this cold air mass tend to progress southwards, bringing very cold and chilly conditions to the areas of northern Canada and USA also. But you can see here on this particular edge of map, you have comparatively warmer air mass over the oceans. Why? Because the warm ocean currents brings the warmer temperatures, develop warm air mass over these regions, which is warm and moist because it develops over the oceanic surfaces. So when these two particular air masses collide, it leads to very turbulent conditions in these areas, leading to the formation of temperate cyclones also. Besides polar frontal zones and Arctic frontal zones, we also have intertropical frontal zones. And these zones are primarily formed in areas near the equator due to the convergence of trade winds from both the hemisphere, from the northern hemisphere as well as from the southern hemisphere, which leads to the formation of intertropical convergence zones called as ITCZ. So although there is not much temperature contrast between these two air masses. Why? Because the trade winds coming from the northern hemisphere are not very different from the trade winds coming from the southern hemisphere in winters and in summers. But the winds and weather patterns resemble to those found along the fronts in the mid latitudes. So typically, we know that the passage of front is accompanied by long lines of cumulonimbus clouds, a rapid wind shift, and a sharp drop in temperature. But in these particular areas, these particular weather conditions are presumably created due to the transition from the warm trade winds of the summer hemisphere to the cooler trade winds of the winter hemisphere in these zones, because of which the equatorial trough disturbance, this particular word is preferred more over the intertropical frontal zones to describe the specific weather conditions in these particular areas, which may resemble to those weather conditions in the mid-latitudinal areas, but the mechanism of precipitation and formation of clouds is entirely different from what it takes place in the frontal areas. So we have equatorial trough disturbance zone, which is preferred over the intertropical frontal zone in these particular tropical areas where trade winds merge with very low contrasting properties, leading to the formation of cumulonimbus clouds and very high precipitation. Summarizing the video now, a front is a sloping boundary between the two opposite air masses having contrasting characteristics in terms of their temperature, humidity, density, etc., and are associated with depression, which tends to develop in well-defined areas, primarily temperate regions of the world. And these are extensive transition zones between contrasting air masses, representing zone of discontinuity where they converge, because of which these regions are often associated with turbulent weather conditions, precipitation, and aggressive wind movement also. So based on the nature of convergence, the fronts can be divided into cold front, warm front, stationary front, and occluded front. And in all these different types of front, we have different types of weather conditions. And with the progression of fronts and different stages of frontal activity, the weather conditions may also change. Major frontal zones of the world are polar frontal zones, Arctic frontal zones, and intertropical frontal zones. Intertropical frontal zones are often associated with the convergence of trade winds and formation of intertropical convergence zones. So basically, the frontal regions of the world located primarily in the temperate regions are the zones where we have unique type of climatic conditions, and these regions of the world often witness turbulent weather conditions with extensive rainfall, aggressively changing wind conditions and prevailing cyclonic activity. So this was all about front. I hope the video was informative. In the next video, we'll be going to discuss temperate cyclones. Thank you so much for listening.